Modern medicine has a superbug problem. Some of these germs laugh in the face of antibiotics, which is not ideal. But our hero may have arrived, and it has 6 legs, a butt that stings, and might be raiding your pantry right now. Researchers have found that fire ants, along with a few other species, are walking pharmacies, and they might be the key to better antibiotics. So we may actually be saved by the same things that are more than happy to devour our secret stash of chocolate. And I know I'm not the only one who has one of those. Ants live in crowded, damp underground tunnels. In human terms, that's a Victorian slum. If we lived like that, we'd be taken out by a common cold in 4 days. And that's being generous. But ants aren't so easily decimated. In fact, they've solved a problem that modern hospitals are still struggling with. Ants have specialized glands that are like onboard bottles of hand sanitizer. They secrete antimicrobial compounds that the ants then rub all over their bodies. Might get a little weird. This becomes a protective layer that keeps superbugs at bay. Remember Bubble Boy? It's kind of like that, but a lot smaller. And if you want to know why ants need such a strong defense, we have to talk about one of the weirdest things in nature. Zombie ants.
They're my family. Take me! Take me! Rains!
There's a group of fungi called Ophiocordyceps that can take over an ant and control its body. They make it leave the safety of the colony, climb up a plant or some other high spot. The fungus sprouts out of the ant's body, and then spores drop onto the other ants below. It's a horror movie of the smallest proportions. To keep the whole colony from turning into very tiny zombies, they protect each other. When a worker comes back to the nest, other ants inspect and clean it, picking off spores before they can start a colony-wide infection. Some species add another layer of protection. They team up with helpful bacteria that live on their bodies. The ants feed and shelter these bacteria. In return, the bacteria make natural antibiotics that help protect both the ants and their nest from harmful microbes. This teamwork between ants, fungi, and bacteria has been evolving for tens of millions of years. Over that time, it's cooked up some very powerful natural chemicals we humans could only dream of. And that's exactly why researchers are now turning to ant chemistry for ideas. Scientists pitted some of these compounds against a range of bacteria and fungi in lab tests. And guess what? They worked. Like, really well. Some of these ant-made chemicals were able to stop or kill Candida auris, a drug-resistant fungus doctors are increasingly worried about. But we need to zoom out for a second. Superbugs aren't one single villain. They're any germ that has learned to dodge the medicines we throw at them. We use an antibiotic, most of the germs die, but the few survivors shrug it off and pass on their super strength to their offspring. Over time, you end up with infections where the usual pills do almost nothing. Doctors have to reach for older, harsher drugs or combinations that come with more side effects, and sometimes there simply isn't a good option left. But ants cracked the code a long time ago. If you pack thousands of bodies into a dark, damp tunnel and don't want the whole colony wiped out by one fungus, you either develop ways to combat it or you disappear. So the compounds in their specialized glands aren't some random stroke of luck. They've been refined by evolution in a very unforgiving test lab, a dark, damp, crowded colony. What excited researchers is that some of these ant-made chemicals hit germs in ways that are different from our standard drugs. That matters because when you attack a microbe from a new direction, it doesn't have decades of practice dodging that move. Right now, no one's grinding up ants and turning them into pills, but the structures of these antimicrobial molecules can act as blueprints for future medications. Chemists can study them, modify them, and try to turn them into treatments that are safer, stronger, and harder for superbugs to outsmart. Now for the part where I ruin the very feel-good movie montage. But don't click away. This is actually the part that tells us whether this discovery really has a shot. There are 3 big reasons most promising compounds never make it into people. 1, they turn out to be toxic to our own cells. which is a bummer. They don't just hurt germs, they hurt us. 2, our bodies metabolize them too quickly. The liver and other organs break them down before they can do much good. And 3, they just don't work as well in the chaos of a real infection as they do in that nice controlled petri dish. Even when something looks good, the timeline is long. It still takes years of testing and trials, and a lot of chances for the project to get shelved along the way. So this isn't a story about a fire ant pill showing up at your local pharmacy next year. It's a story about where the next generation of treatments might come from. And that part is genuinely encouraging because we've been here before. Many of the drugs we rely on today started with something living. Mold on a plate, soil bacteria, compounds from plants and marine creatures. Nature has provided the solution to more problems than we can count. And every once in a while, humans figure out how to use them to their advantage. Ants might be on the list now. Their survival system gives researchers a fresh set of starting points at a time when the old playbook against superbugs isn't cutting it anymore. Even if none of these exact molecules become medicines, the knowledge is still valuable. It can point scientists toward new ways of attacking germs or inspire designs for synthetic drugs that work in similar ways, but are easier to use in patients. So the problem isn't solved, but science is opening another door. And in a world where infections are slowly catching up to our best defenses, having more open doors is always a good thing. If you're looking for more good news in your life, be sure to check out this video right here. And if you enjoyed this video, please give it a like and consider subscribing so we can ignore all the bad news together.